And then go to the part about reflection. Now we have to consider if the point is reflected in the x-axis or y-axis. Then let's try to look at a point P again. And we always say that P, the coordinates of P, that is xy. And if the point is reflected about the x-axis. Now let's look at the figure here. If the point is reflected in the x-axis, so here should be the image of P. And then you can see that the point P and the image of P, they form a vertical line. Then for the vertical line, their x-coordinate should be the same. That's why only the y-coordinate is changed. But how is the change? And it will from positive become negative. And that's why you can see that the coordinates of the image of P, if it is reflected in the x-axis, the resulting coordinates should be x and then minus y. And if sometimes when the point is reflected in the y-axis, the second case is that if the point P is reflected in the y-axis, you can see that now then the image of P should be here. And then you can see that the point P and the image of P form a horizontal line. And in this case, their y-coordinates should be the same. And that's why you can see that the coordinates are negative x, y. So you have to remember such changes, the image after the reflection. And I think you may always refer to this figure to think about that. What is the change of the x-coordinate or the y-coordinate? And then let's look at some example about the reflection in the x-axis or the y-axis. Let's look at example 12. And now you can see that P is reflected in the x-axis to a point Q. That means P is the original point and Q is the image. Then we have to find the coordinates of Q. And then in our learning before about the reflection in the x-axis, we know that the x-coordinate should remain unchanged and the y-coordinate will become negative y. So you can see that the y-coordinate of Q should be negative of the y-coordinate of P, and the y-coordinate of P, that is negative 3. And that's why we get the y-coordinate of Q is 3. So I may just write down the answer like this. The coordinates of Q are 4 and 3 because 4. That means the coordinate of Q is the same as the coordinate of P. And next is the y-coordinate of Q should be negative of the y-coordinate of P. So negative 3 will become positive 3. And next is that when you look at part B, if M is another point, and then it's reflected in the y-axis in this case. And if it is reflected in the y-axis, the x-coordinate should be changed. And how changed should be negative, and then the y-coordinate of the original point, that is negative 8, because the x-coordinate of M is negative 8. And that's why the x-coordinate of N, it is 8. And next is that the y-coordinate of Q should remain unchanged. And that's why I can get the answer here. And then I can write down the coordinates of N as 8 and 5. So I think the idea is not quite difficult. But remember, I told you that you can remember the graph, the figure that in the previous slide. So try to remember the figure. And in most of the transformation, you better to draw the figure. Even though here the figure is not given, then you may draw the figure and then try to have a look about that. Then you know that what you have to do. And then for the next one is to discuss about the reflection in the horizontal or vertical line. Again, if we have a point P, X, Y, and then which is A units from both horizontal lines, for example, is L1 and L2. And the distance between the point P and L1 is A. Also, the distance between point P and L2 is A. And then how to get the image after the reflection of L1 or L2. Then let's look at the figure here. When P is reflected in L1, because L1 is above point B, so after the reflection, the image of P should go up. That means it is translated upward, right? That's why if it is translated upward, then I know that the x coordinate should keep unchanged, but the y coordinate should plus how many units? That means the distance between these 2 points. And then for the reflection, if the distance between point P and L1, that is A units, then after the reflection should go from A units more here. So the total distance between P and the image of P should be 2A. And it is going up. That's why the y coordinate should plus 2A. And in the same case that if now point P is reflected in L2, you can see that L2 is below point P. So the image will go down. Okay? If it is going down, the same idea that here is A unit, and then the image of P also A unit away from the line L2. That's why the distance between P and the image of P also equals to 2A. But now because it is going downward, that's why the y coordinate should minus 2A. So in the consideration of the reflection, you may think about that just like the translation that you had learned in the previous section. But I told you that you better to draw the figure. Then you will see the movement clearly about that it is going up or going down. Then you know that you should plus or minus for the y coordinate. And here is the reflection about the horizontal line, because L1 and L2 is the horizontal line. So it is only move the point up or down if it is reflected in a horizontal line. And for the next case is that when the point is reflected from the vertical line. If it is from the vertical line, the same idea that also I just say that the distance between the point P to L1 or L2 is also equal to A. If it is reflected about the vertical line, the image should go to the right-hand side or left-hand side. If the image go to the right-hand side, then the x coordinate should plus. Okay, plus what is the distance between them? It should be 2A. So the main idea is that you have to find out the distance between point P and the line L. That is A unit. What is the value of A? That means what is the distance between the point P and the vertical line L1. Then remember, the distance between point P and the image of P should be 2A, because here you should go for further A units. So totally the distance between the point and the image should be 2A. If it is going to the right-hand side, then x plus 2A, and the y coordinate should keep unchanged. And if it is going to the left-hand side, that means if P is refracted in L2, that means point P is moving to the left-hand side, then the x-coordinate should minus 2a. Okay, so now next we will consider some example about that when the point is refracted in the horizontal line or a vertical line. And the important thing is that you should know the distance between the point P and the line, I mean the vertical line or the horizontal line. That means the important thing is that how to calculate A. What is the distance between the point and the line? Then you can find the coordinates of the image easily. So let's look at this example, example 13. And for example 13, you can see that now there are two straight lines, L1 and L2. One is the horizontal line, and then this line, I mean L2, is the vertical line. And now the situation is that a point Q is the image when a point P is here. The coordinates of point P are -1, 1, and which is refracted in L1. Then let's look at L1. L1 is here, the horizontal line here. When the point P is refracted in L1, that means the image of P should be here. I just draw it roughly. I told you that the picture, I mean the figure, is very important in doing such problem. So you may draw the figure roughly like this. And then you know that after the refraction, the image should be here. And we call the image as Q. And then next is that, okay, maybe I draw again about this, sorry. Okay, after the refraction here, okay, this is the point Q. And then now you are asked to find the coordinates of Q. That means your problem is that you have to find the distance between point P and the line, I mean the line of the refraction, that is L1. That means here is A unit, okay, A units. But what is the value of A? Just try to think about that. What is the distance between the point P and the line L1? And actually this is the vertical line. Then we just need to consider the y coordinate of point P and this point. And for this point, actually you no need to write down the coordinates of this point. Just look at this straight line, I mean the horizontal line L2. I think every point lying in this horizontal line L2, the y coordinate should be -2 because you can see the point M here. Can you see that? M and this point are lying on the same horizontal line. That's why their y coordinates should be the same. So the distance between the point P and L1, that means A, should equal to 1 minus -2. Because I just need to compare the y coordinate of this point. Or some of you may ask that, actually, can I write down the coordinates of this point? Actually, you can. Because if you look at this point, the x coordinate should be the same as the x coordinate of P, that is -1. And then look at this horizontal line, should have the same y coordinate as M, that is -2. So this is the coordinates of this point. Then you can find the distance between P and L1 easily just by using 1 minus -2, just the difference of their y coordinate. And I also find that in the previous exercise, I mean in exercise 8b, you learned how to find the length of the line segment. Remember, you should use the larger number minus the smaller number because now 1 is larger than -2. But in the previous exercise, I mean exercise 8b, I found that some of you will use -2 minus 1, then you get the negative answer. And when you are talking about the length, it should be positive, should not be negative. So you always need to use the larger number minus the smaller number to get the positive value. That's why you get the distance between P and this horizontal line L1, which is equal to 3. After you get this, you can find the coordinates of Q easily. The coordinates of Q, I may just write down Q and then equals to, and because this is the vertical line, okay, and the Q is only translate the point P from here, just translate point P downward. For how many units? For 2A units, because here is A, and then this part also equals to A units. So for the X coordinate of Q, it should be -1. But for the Y coordinate of Q, I should look at the original point 1. And because it is going down for 2A units, so it should be minus 2 times A. Okay, 2 times A. A is equal to 3. And then simplify the calculation about this. 1 minus 2 times 3. And 1 minus 2 times 3, it is -5. So this is the answer for the coordinates of Q. That means in part A. And next is that, part B. Part B, you can see that I may show you the solution of part A. You may see the presentation about part A here. Because the distance between point P and L1, that is 1 minus 2, so you can get that the answer is 3 units, and then you can express the coordinates of Q like this. And then for part B, because you can see that I may go back to the previous line, okay? I may go back to the previous one. Go back to the question. Let's look at the question. For here, for part B, after you get the coordinates of Q, okay, before I find that the coordinates of Q, the point Q should be here. And now R is the image when point Q is reflected in L2. So here should be the point R because it is reflected in L2, okay? And Q is the original point here, and R is the image of Q. And then also in this case, you need to find the distance between the point Q and L2. And because this is the horizontal line, so you have to use the difference of the X coordinate of point Q and this point. And the X coordinate of this point is easy. It should be the same as the X coordinate of M. That's why here A should equal to 1 minus, and the X coordinate of Q is -1. That's why you find that A equals to 2. Okay? And then at the follow-up, I don't want to continue to discuss about the follow-up. I think the most difficult part is to find the distance between the point Q and the line L2. Because this is the horizontal line, remember, you have to use the difference of the X coordinate to find the length here. A here. And then after you get A, then you can write down the solution like this, okay? I may show you the solution of part B here. You can look at this line here. Distance between the point Q and L2, it should be 1 minus -1, because the X coordinate of any point on L2 is 1. And then you find that the distance is equal to 2, that is the A. And then the coordinates of R, here, the X coordinate should be changed because it is moving to the right hand side, so it should be plus 2 times A. And A here, this is A, and this is A. The original coordinate of point Q, the original X coordinate of point Q, and then plus 2A. And then the y coordinate should be the same as point Q. So just copy the y coordinate here, -5. And then you will get the answer here. Okay? And then you will get the answer about this. So this is the part about the reflection. And I hope that you can get the idea and also try the worksheet about the part of the reflection. Okay?